All right, so we need to create a file system on this partition before we can start using it. And there's several different options here on Linux. There's ext2, ext3, ext4, and this is the extended file system. And all a file system is it's a table that exists at the beginning of a partition that says where certain information starts and ends, or where it's located. Maybe fragmented all over the disk. So we have file 1 start could be at byte 1000 over here somewhere, and then we'll know that file 1 end is over here. But this file system table essentially indicates to the operating system, where it can find the correct zeros and ones that it's looking for so that it can do what it needs to do. So this file system table at the beginning provides organization. Otherwise, these, again, are just zeros and ones. So a quick way, when you delete a disk or you format a disk on Windows, if you choose quick format, for example, and this is an important point, all it does is it deletes the file system table at the beginning of the disk when you do a quick format. It doesn't do anything to all the zeros and ones. So technically, that file that was at byte 1000 out here and ended at like byte 1530 still exists when you do a quick format. And those files can be forensically recovered without a whole lot of effort. And we'll take a look at forensic tools in the cybersecurity class and how to do that. So quick formats are insecure, and essentially you're just wiping out a file system table. Right? So there are several different types. There's, as I said, extended 2, extended 3, extended 4, and we don't need to know the ins and the outs of the different file system types for this class. If you're going to get a certification like Security Plus or CCNA, yeah, there are some things we need to know. There are file systems, just so when you recognize them, JFS is a journaled file system. We have Reiser FS. And if you're interested in looking up Hans Reiser, the individual who created that operating system, you'll see that he is currently incarcerated. The guy who created this one, Reiser FS. We have XFS, and then we have this one, which you see quite a bit, and people pronounce it Butter FS. Right, and there are others, but the big ones on Linux are Extended 2, Extended 3, and ext4. Just an FYI on those. So let me log back in here to my Linux machine and let's do that. So we've got our SDB1, which if I do a CF disk, you can always check it with this. And I made a mistake there. You don't want to do dev SDB1. You want to do a dev SDB, because that's where the partition table is. That's where it's going to look to get the information. And we can see that we do have dev SDB1, which is a partition that's on the system that we can now start to work with. Now, if there are already files on a partition, and we do what we're about to do right now, which is create a file system table, all the files on that partition will be lost and would have to be like forensically recovered, which can be a very time-consuming, laborious process. So you want to be careful with this command as well. I'm going to type mkfs dot, and then I'm going to hit tab twice. And you can see these are mkfs commands. It stands for make file system. And so these are the ones we could do extended 2, extended 3, extended 4. We could do file allocation table. If we had a USB drive that we wanted to use on both Windows and Linux, we'd most likely use that one. We could create NTFS file system, which is the standard Windows file system we could create as well. So if we wanted this drive to be portable between Windows and Linux, we'd have to choose FAT or NTFS, because this extended 4 and extended 3, not natively recognized by Windows. Okay, let's go ahead and make it ext3. We're going to do dev SDB, and we're going to use the first partition. So let's go ahead and create a file system table there. It's going to go through, and it's going to tell you that it's creating what it's creating. I'm going to pause the video while it does that. and that operation is completed. Now on Windows, when we assign file systems to the system, we assign like drive letters. You'd have like your C drive, your D drive, your E drive, your F drive, right? That's not how it works on Linux. In Linux, everything is put into a folder somewhere. We can do this on Windows, and we will when we do our Windows unit. You can take a file system and just stick it in a Windows folder like this. But most of the time on Windows, you're going to have drive letters. So let's go to cd / down at the very beginning. And I'm going to go ahead and do mkdir drive _2. We'll just create an empty folder. And I'll just chmod rf777 drive 2. And so we're now going to use the mount command. And the mount command is essentially what we do is with mount, we're going to take a partition that contains a file system, and we're going to stick it on a folder. We're going to mount it into a folder. And so mount takes two different arguments. We'll use this one quite a bit as we work through some of these. Mount dev sdb1 and then drive _2. And if I cd into drive 2, if you type ls, you will see lost and found. That's the way you know that this file system has been created, because we have a lost and found directory in there. That's one of the sort of hallmarks BXT4 is you'll see that lost and found. So now we have access to that 10 gigabyte partition that we created, and we can start creating files and folders here. Let's do a df h, just like that. You'll notice that down at the bottom, we have dev sdb1 is mounted on drive 2. We have 9.3 gigabytes available, and the size is 9.8 gigabytes. Used is 23 megabytes. So we haven't put anything in there, but there is obviously data there. In the cybersecurity class, we'll go in and we will look at file systems in a little more depth. But for this, we just kind of need to understand the structure and how they work. Okay, so here's how you get credit for this checkpoint. You either raise your hand if you're in my class or in one of our classes, call the instructor over and show that we do indeed have lost and found inside of drive 2. And when you do a DFH, we have drive 2. SDB1 is mounted into the folder drive 2. So let me lay it out here. I'll spell it out. Watch this. So here's checkpoint 1. This is video 3. We're going to demonstrate that the lost and found can be seen in the drive 2 folder, and demonstrate that df-h shows the dev sdb1 is mounted on drive 2. All right, in the next video, we'll continue working with file systems, and we'll show some other ways that we can sort of utilize some of these commands.